Thanks very much. It's great to be here, everyone. So I'm going to present some work that's done by a large group of people, both internal and external to the Marine Institute, and the co-authors of the recent report on Irish Ocean Climate and Ecosystem Status Report 23. So to provide you with a little bit of context, we all know that the ocean has lots of different types of habitats and ecosystems that sustain marine life. And the Irish people, about 40% live within 5 kilometres of the coast, and everywhere in Ireland is at less than 100 kilometres from the sea. And the huge territory that we have, which is about 880,000 kilometres squared of marine area, sustains the livelihoods of many people. And 3 of the top sectors are shipping and maritime transport, tourism and leisure, and seafood, with the ocean renewable energy becoming very important now as we face the challenges of climate change. So in Europe, the observed impact of climate change on ecosystems is the confidence in the attribution to climate change is high or very high. The IPCC recent report, which outlines the physical basis for climate change globally, informs us that the observed changes in the ocean are things like increased surface temperatures penetrating deeper into the surface layers. We have decreasing oxygen levels in the ocean. We also have increased ocean acidification, and all of these type of changes that we're observing have impacts on ecosystems that are quite negative in some cases. However, it's important to know that change does not happen everywhere at the same time, exactly the same way. So regional differences are very common. And a good example in Ireland is where you have sea level rise, and it's likely to be more devastating and have more of an impact in the south coast than it would on the north coast. And this is due to many reasons, and one example would be the rebound of the ice sheets. So in terms of policy, the work that we do is very much influenced by the international policy, and things like the convention, the Paris Agreement would be very much setting up the scene for us internationally. And then when you look at it in terms of Ireland, initiatives such as like harnessing our ocean wealth and the climate action regional plans very much influence the type of work that we're doing. So the adaptation plans for the seafood, it was very important for them to gain understanding about climate change, and also to start a discussion on how we're going to start to adapt to climate change. A decision was made to look at case studies. So we've got 6 case studies, and these include fish, harmful algae, art and science, seafood infrastructure, plankton, and ocean acidification. So, for example, in the case of seafood infrastructure, what's of importance to them is like sea level rise. And with the rising oceans, we need to be able to observe and have in situ observing systems to be able to monitor what's happening and what's changing in the future, and also have good information to feed into numerical models so that we can look at projections and the types of impacts that are going to happen in the future. So this leads me then to the work that we've been doing recently. And so last month we just released a report on the Irish Ocean Climate and Ecosystem Status Report. And I have 3 copies here. and we only printed off a limited number. However, if you have a camera there, you can take a picture of the QR code and you can download it online. So I have 3 copies with me, so if people prefer to read hard copies, then reading online, first up gets them at the end of the talk, okay? So this report was very much a huge collaboration. It was led by the Marine Institute, but we worked with a number of higher education institutions around Ireland and a number of public bodies to produce it. And the authors have used long-term time series that are available and all other available information that they could find, including the scientific literature, to produce key findings and recommendations that we would hope would inform policy. So we're looking at individual chapters for different disciplines like atmospheric drivers. We have ocean warming, sea level rise in the physical oceanography chapter, ocean acidification in the ocean chemistry chapter, among other things like nutrients. You'll have to read it. Phytoplankton and commercial, or plankton and fisheries abundance and distributions, and seabirds are the main things. And then the backbone of all of this is the observations. So there's a chapter for the first time in our climate report on infrastructure and the essential ocean variables that are measured. So I'm just going to run through some of the key findings from the report. For the atmospheric drivers, the ocean and the atmosphere is very tightly coupled. And we know that the ocean influences both the weather that we actually experience and the climate. It regulates the climate. And so it's really important that we had this chapter in it, even though it's not the ocean, but like the heat content and the atmosphere will drive things like wave heights and water currents and surface waters. So looking at the different types of variability that we see in our part of the world, one of the main drivers would be the North Atlantic Oscillation for our winter weather. And a negative NAO will tell you that you'll have a cold, dry winter, whereas a positive will be a wet winter. However, the NAO is influences very much the shelf seas like the North Sea, and you'd have a lot of connection with biology there. But in our part of the world, it needs to be combined with other patterns and other types of atmospheric variability, such as the East Atlantic pattern and the Scandinavian pattern. And so if you combine that, it's more appropriate for the type of weather that we experience. For the physical oceanography, the Atlantic meridional overturning circulation, or what everybody usually refers to as the Gulf Stream system of currents, is very important to Ireland. We're a little island in a massive Atlantic Ocean that's influencing our weather. And so this is what influences our mild climate. Without it, we'd be as cold as Canada or other parts at similar latitudes. And so they've been finding recently that there's a decline in the fluxes or flows of these currents, and they've used some proxies as well to indicate that a stalling of this has already occurred. So this is why we're seeing a big cold blob in the Atlantic. However, if you go to the shelf seas and coastal areas, we're seeing an increase in temperature. And so our waters close to the coast have warmed since the 1980s. Plus, out in the ocean as well, it's quite consistent too with the global kind of increases, but it's been dampened by this changes with the AMOC. And we're also seeing larger sea level rise, especially in Cork, and Dublin actually, interestingly enough, is about twice the global average. So in terms of ocean chemistry, which is really important to driving biological habitats, some of the research that we've done in offshore waters is showing that ocean acidification is occurring with a reduction in pH of 0.02 units per decade. However, if you come into the coasts, you can find that the waters can be both a sink and a source. With certain times of the year, CO2 is a sink in spring and summer, and it's also then in autumn it can be a source up into the atmosphere. So phytoplankton, which are microscopic plants, are really important for the base of the food chain, and we've been seeing in Irish waters that there's an expansion of the growth season. So you might see it as well when you're cutting the grass, that you might have to do it earlier and then later in the year. So it's a similar type of thing in the ocean. In terms of commercial fisheries, we're very concerned that the declines in the overexploited stocks may be exacerbated by climate change. However, disentangling climate effects from other pressures, including fisheries, remains a challenge for scientists. And there is some evidence that there's increasing warm water species to the south of Ireland that might allow for new fishing opportunities. So an example of that would be anchovy. There is also a need to have a very deep understanding of your subject area. And a good example, not to always attribute climate change to a sudden change in the environment, would be the snake pipefish. There was a massive increase in this in the early 2000s, and it was attributed to increasing sea surface temperatures. However, come 2008, the number started to decline again, even though the sea surface temperatures were continuing to increase. So it's a little warning tag that really you need to have a deep knowledge of your subject. So in terms of seabirds, the key findings were that half the seabirds species globally have declining populations. 89% of seabirds affected by climate change are also affected by other threats. So things like overfishing, hunting, trapping, and disturbance also impact the numbers. So it's also difficult to disentangle these different threats. Populations of little terns may be more vulnerable to sea level rise, as well as species that nest on coastal beaches, such as the ringed plover. Seabird mortality during storms is likely caused by starvation, as seabirds can't effectively find their prey in these extreme conditions when hunting. So we also included a chapter on the land-ocean aquatic continuum because they're very strongly linked. And one example of the many findings in this part of the report is that the return of Atlantic salmon in Burrishoole after one winter at sea have declined by almost from 1,800 in 1973 to 279 in 2014. The reduced returns have been correlated with increased temperatures and a decreased abundance of their food, which is plankton. So the chapter on numerical modelling, so this is like your digital version of the ocean, where you can actually do experiments and look at what's happening or do projections or predictions into the future, shows us that significant wave heights are projected to decrease in Irish waters, particularly in the summer and winter months. And mean sea level for the Irish coast is projected to increase by between 25 centimetres to 1 metre. And this will, of course, depend on the rate of greenhouse gas emissions. Projections in salinity of the southwest coast also, in a recent project that we did, is showing that it's becoming fresher and less saline up to 2035. So there's a load of recommendations that we hope will inform policy, and so I would encourage you to have a look at the report. I'm just giving you another chance to take a picture of the QR code. So what's the next steps? So we've only it feels like as if we're only just beginning the work. We need to engage with Ireland's National Framework for Climate Services. We also need to enhance the digital climate services that we're developing with our co-developers to ensure we get what we need and it's useful. We need to enhance our communication and outreach on marine climate matters, and we need to engage with the National Climate Action Plans. And we also need to continue to gather marine scientific evidence to support adaptation and mitigation decisions. And this is just, I would stress on this, because if you don't have any measurements or any ocean observations, then you can't actually make decisions or be informed about what's actually happening. So it's really important. So just to finish up the talk, I thought I would give you a couple of examples of some of the projects that we're working on, that we're going to use to support, their tools to support climate adaptation and climate information. So one example is from a PhD student we have called Catherine Jordan, and this is between the Marine Institute and the University of Galway. And Catherine has been working with our colleagues in NOAA, which is the National Oceanographic and Atmospheric group over in the US, which is the same as our counterpart in the USA. And they have this particular algorithm that can pinpoint certain harmful algal bloom species. And so we tested it in Irish waters and we found a bloom, and it was working really well. So that's really good for us. She was also looking at AI technology and cheap microscopes and smartphones. So you can look at the swimming behavior of these organisms to actually identify them. And this is great because this then means that it can go out into a citizen science project if needed, you know, so that was really good. Another example of a project I'm involved in is called EuroSea. It's a European-funded project, and we've developed an ocean observatory site in Ireland and one in Spain. And we've worked from the very start with the aquaculture industry to develop a platform that shows you the in-situ data, both historical and the current data coming from the data buoy, satellite remote sensing, and numerical modelling to produce predictions. And one important thing with this is that actually the aquaculture designs what's on their site. So the Spanish one is different to the Irish one. The essential ocean variables that they want is different because they have different risks and needs. And this is an example of an important extreme marine event that is of interest to the Irish aquaculture industry, and it's on marine heatwaves. So you don't just get them on land, you also get them in the ocean, and it can have devastating effects on ecosystems. So here you're seeing what's happening at the minute, and then what's going to be projected into the days ahead or the couple of weeks. We also have seasonal forecasts that you can look at into the coming months to give you an idea of if it's likely to happen or not in your area. Another example of some of the work that the modelers are doing, which is excellent because it's a high resolution model. So some models are very low resolution, so you get the general gist of an area, but as you get into like a couple of 100 meters, then you get a better feel for what's happening in your environment. And here, freshwater outputs from rivers really impact the cultivation of oysters, can have a very negative impact. So they're looking at freshwater in Inner Galway Bay, and you can see that it's actually very fresh in the earlier part of the year and less saline than later in the year. This is the colours here. And then finally, what surprised us actually in a project that was funded by the EPA, it was a JPI Climate project called CoCliME, and we met up with the Climate Action regional offices, and they were brilliant to work with, and they educated us a lot. And one of the key things that they wanted was to be able to inform the communities that they serve, and so they wanted climate messages and information that was easy for people to digest. And so this led to us developing a load of infographics. And this one here is just an example of a harmful algal bloom infographic, because that was what the project was about. But it was very educational and very much a learning process, and it actually takes an awful lot of time to do this if you're going to try and do it proper. So these will be, we're upgrading our website, so you'll be able to download these, and we'll put up the ESP files so that you can actually download the layers and reuse them if you want for something else. And so, just to finish, I just want to say ocean observations are critical for the information that you need for climate change. And apologies, I just went over slightly, sorry.